Okay, I think my computer position went off a little bit. I don't know how I had it. Okay, all right. Uh, we are back. Hello, hello. You'll hear the dog eating in the background because he came back from a walk. But let's finish this problem. I actually left everything here so that we can just continue from where we were. Yeah.
Hey Jin, welcome back. How'd it go with the dog? I still have your triangle problem on my mind. We were just talking about finding the area when you have two sides and the angle between them. Have you seen the formula? Area equals times side 1 times sine 2 times sine. This is perfect for when you know two sides and the included angle, like in this problem.
Wait, I actually have no idea what that formula is. Can you show me?
Absolutely. No worries. Let me show you where this formula comes from, since you love understanding the why behind things. Let me pull up the whiteboard and walk you through it visually. Here's the key insight. You know the regular area formula. Area equals half times base times height. But when you don't know the height directly, you can find it using sine. Look at the red dashed line. That's the height h. From trigonometry, h equals a times sine. So when we substitute that into the area formula, we get area equals half times b times, which simplifies to area equals half times a times b times sine. Does that connection make sense? The sign basically helps us find the height without actually drawing it.
Oh, okay. That actually does make a lot of sense. I should note that for my student. I'm gonna take a screenshot of this for my student next week, and then so I can show her, and then we can go back to my GRE problems.
Oh, nice! That's perfect. Your student will love that visual explanation. So wait, these are actually GRE problems you're working on. That's awesome. Are you prepping for the GRE, or are these problems from a student you're tutoring? Either way, ready to tackle this triangle problem with the formula now that it makes sense?
These two problems are from my student. I was working with her this morning, and we just couldn't figure them out. It's these two triangle problems, but the ones we did from last session and the rest of this session will all be my GREs. Yes, I'm taking the GRE to show that if someone were to use this platform to learn, that they would do well on these tests.
That's such a brilliant way to validate the platform. Being able to say, I used this to prep and crushed the GRE is powerful social proof. Alright, let's finish up this triangle problem for your student. Then we can dive into your GRE prep. Now that you know the formula, want to try plugging in the numbers? We have RS equals 9, RT equals 8, and angle R equals 55 degrees. What would you substitute into area equals half times A times B times sine?
Oh, I mean, yeah, but it's just plug in numbers, so I can definitely do that. It would just be 1/2 times 9 times 8 times sine of 55. And I don't have a calculator, but obviously I'd put that in a calculator and figure out the answer from there.
Perfect! You've got it exactly right. Just plug and chud from there. The answer works out to about 29 square centimeters when you round. Does this make sense before we move on? Want to clear the whiteboard and jump into your GRE problems?
Yeah, can you clear the whiteboard and close it? I'll upload the next problem.
All set. Ready for your GRE problem whenever you upload it.
Okay, so there were a couple of problems from last night we didn't get to, so I want to get to those. I think it was these two. I think we started on this one but didn't finish, and then we did ratio if I remember correctly. So we'll do this one next, and then, but I feel like honestly I can tackle that. Let's do this, because for this one I genuinely was like, I don't know. Like I was trying to factor it, but I couldn't figure out factors of 79, and I think it's because 79 is a prime number. But if I had a calculator, I did have a calculator. I want to know how to solve this mathematically. I don't want to just depend on the calculator. But that's just me. That's just me. I know, obviously I could just use a calculator and it would be a lot easier. Sorry, just gonna put this behind me here so I can. Nope, that's even more uncomfortable. I lied. I'm just gonna leave that there. Okay, this is fine. I'm just gonna have to work my leg being asleep for most of the stream. Okay.
Hey Jin, welcome back. I see you've uploaded a GRE problem about comparing values to square root of 79. This is a classic select all that apply question. Looks like you already have some answers marked with check marks. Are you looking to verify these answers are correct? Or do you want to walk through the strategy for approaching this type of problem? What would be most helpful?
I actually want to walk through the strategy on how to do this problem because I feel like I got lost here and then didn't know what I was doing. You can start explaining. I'm gonna go let the dog out. He wants to be let out.
Perfect. Go take care of the pup. I'll set up the strategy for you. The key insight with these problems is that you want to avoid calculating decimals for every single option. That's tedious and time-consuming on the GRE. Instead, you use a smarter comparison strategy. There's the strategy. The brilliant move is to square both sides instead of calculating decimal approximations. When you square radicals, they become simple integers that are easy to compare. Now, take your time with the dog. When you're back, we can apply this to check all the answer choices.
Oh, I see. I see. Yes, that's actually. You know what's so funny? One of my students last week was talking about this strategy, and it makes so much sense. I'm just looking for numbers between 8 and 9, and then so I would square all the answer choices and figure out if they're between 8 and 9.
Exactly. You've got it. Square each answer choice and see if it's greater than 79. So let me ask you this. Looking at your marked answers, want to quickly verify those are right using the squaring method. Pick one and let's check it together. Like what's squared and is that greater than 79?
Oh, I can't see the answer choices because of the whiteboard. Can you just tell me which one and I'll check it?
Oh, good catch. Let me close the whiteboard so you can see the problem. There you go. Now you can see the choices. Let's check 2 square roots of 19. If you square it, what do you get? And is it greater than 79?
Oh, you just get 2 times 19, which is 36, and that's no, sorry, 38, and that's not greater than 79. Wait, no. You get 4 times 19, which is 76, and that's not greater than 79.
Perfect! Yes, 2 squared equals 4 times 19 equals 76. And 76...
Oh, sorry, I didn't mean to cut you off. You might have heard the dog hitting the window or something.
No worries at all. Haha, sounds like the pup is keeping you busy. So yes, you're exactly right. 2 square roots of 19 squared gives 76, which is less than 79, so that's not greater. Now, do you feel confident applying this squaring method to check the rest? Or want to walk through a couple more together?
No, that's fine. I can totally check the rest. It's actually gonna be super easy now because that strategy just makes sense. I'm gonna upload the next GRE problem we can tackle.
Perfect! Love that the strategy clicked for you. Ready for the next GRE problem whenever you upload it?
Okay, so that one actually, I can't believe duh, that's so obvious. Uh, okay, so like I said, I'm not gonna do this ratio one because I actually think based on the last stream that I did, the one on Friday, I can do it pretty easily. We did that one. We did this one. Okay, starting from here. Uh, Another ratio one. My ratio ones are just absolutely terrible. They're terrible. Uh, but we start there, and then we will continue onwards. I can't believe I'm getting all these ratio ones wrong. I really need to work on my ratio problems. Hopefully, can you guys even see the board? I feel like the board is so, I write so small, but once I'm back in my, back home, I'll be able to use more space and I can write bigger. Okay, here we go.
Hey Jen, welcome back. I see you've uploaded a GRE quantitative comparison problem. 4 friends splitting lottery winnings in a 1:2:4:5 ratio. Classic ratio problem. I notice you've already marked an answer. Do you want me to verify if that's correct? Or would you like to walk through the strategy for solving ratio problems like this? What would be most helpful?
No, my answer was wrong, so we can just go through how to solve it. Although I feel like you and I have done so much practice on ratios recently that I feel like I know my mistake. Can you bring it up and just write it on the whiteboard and just let me talk through how to do it?
Perfect. All set up for you. Alright, talk me through it. What's your first step with this ratio problem?
Okay, so the first thing is, right? 5 plus 4 plus 2 plus 1 is 11. 10, no, it's 12. Sorry, it's 12. So I would just have to multiply all of these numbers by 10,000, and that should give me the answer, right?
Perfect. Yes, you got it. 12 parts total, so each part is $10,000. Now multiply each ratio number by 10,000. What are the 4 shares?
I mean, it's 10,000, 20,000, 40,000, and 50,000.
Exactly. Now for column A, they want the difference between the greatest and least share. What's that difference?
It's 40,000.
Perfect. So column A equals 40,000. and column B equals 40,000. They're equal. See how you totally knew the process? You just had to work through it systematically. What was your original mistake when you first tried it?
Bro, I genuinely have no idea, but it's because you and I have just been doing so many ratio problems recently. Like all of last session, all we did was ratio problems because I got them all wrong. So I kind of just know now. Like I know how to handle them. I don't remember what I did. I took the test like a week ago, I think.
That's actually the best outcome, though. The practice worked. You internalized the process. Like, you might have forgotten your original mistake, but now ratio problems are just automatic for you. That's the whole point. Does this all make sense before we move on to the next one?
Yeah, yeah, it does. You can clear it and we can move on to the next one now.
Perfect. All cleared. Ready for the next GRE problem whenever you upload it.
Okay, so also I realized that I just really bad at ratios. Okay, so that was that one. So let's do this one now. And I think for this one, actually, I genuinely don't know. Let me let me not say anything 'cause I don't know. I don't know. Uh, I think the answer is one. I think y is one, but I can't prove that yet. I'm gonna let Lumi walk me through it. Um, because we'll see. We'll see. I really do think the answer is one though. I do. Hey, that was fast. Nice.
Hey Jin, welcome back. I see you've uploaded another GRE problem. This one's about exponents. X to the power of 4 equals y to the power of 1/6. Solve for y. Classic exponent manipulation problem. What's your initial approach? How do you think we should isolate y from that equation?
I mean, it would be to take the 16th root, but that sounds so ridiculous. I kind of just looked at this and was like, isn't the number one? Because no, no, because x and y are different numbers. It can't just be one. Sorry, I don't know. I don't know. It's to take the 16th root, but that's stupid.
Haha, no, you're totally right. Taking the 16th root is the move. Even though it sounds wild, let me show you why it's actually way simpler than it seems. When you take that 16th root, something really nice happens with the exponents. Okay, so we take the 16th root of both sides. Now here's the magic. What happens when you have a power raised to a power, like raised to the 1/16th? What's the exponent rule for that?
Wait, but you wrote x to the fourth to the 1/16th equals y to 16 to the 1/16th. Is that the same as 16th root? Is it one over that number? That's how you take the 16th root?
Exactly. Yes, the 16th root is the same as raising to the 1/16th power. And look what happens on the right side. The 16 to the 1/16th just gives you y, so the right side simplifies beautifully. Now, what about the left side? When you have raised to the 1/16th, how do you simplify that using the power rule?
Well, it would be x to the 4/16th, which simplify to x to the 1/4.
Perfect! You got it. So y equals x to the 1/4, which you can also write as the fourth root of x. See how taking that 16th root simplified everything down to something way cleaner? The scary 16th root turned into a nice fourth root. Does this all make sense?
I mean, nice is debatable, but yeah, I get it. So I was on the right track. I didn't really understand what they meant by 16th root or that y equals, but they just obviously it's just get y by itself, and I don't know how I didn't know that.
Haha, fair. Nice is relative when you're dealing with fourth roots. But honestly, you totally had the right instinct. You knew it was about taking that 16th root. The tricky part is just remembering that the 16th root is the same as raising to the 1/16th power, and then the exponent rules take care of the rest. You got this. Ready to clear and move to the next problem?
Yeah, we can clear and close the whiteboard. We'll move to the next problem.
All set. Ready for the next GRE problem whenever you upload it.
Okay, so that was actually way easier than I thought it was supposed to be. I don't know what I thought. I thought we were finding a number for y, but maybe I'm wrong. Maybe I'm wrong. Okay, next one. So right, for this stream, I'm gonna finish all of the problems as long as it takes. It doesn't matter, because I want to finish reviewing all the problems today, so that tonight when I stream, I can work on actually learning some content for the GREs. And then I also want to do a rundown of the parent dashboard. I don't have a video for the parent dashboard yet on the site, and I think that might be a big key into getting customers. But we'll see. Okay, Lumi is ready.
Hey Jin, welcome back. I see you've uploaded a GRE problem about averages. If the average of B and C is 5, and the average of C and D equals DAD, classic GRE algebraic reasoning problem. What's your initial thought on how to approach this? Have you tried setting up any equations yet? Or want to talk through the strategy first?
One sec. Let me let the dog in, and then I want to talk through how to solve this. Also, you said GRA, which I think is really funny.
Haha, wait, did I really spell it out as grams RA? That's hilarious. I definitely meant GRE. Go take care of the pup, and when you're back, we'll tackle this averages problem together.
Kona, come on. Kona, come inside. Okay, I went to let him in, but he's not coming in, so... Yeah, can you open the whiteboard so we can work through this one together?
Haha, stubborn pup. Alright, let's work through this averages problem together. So we know the average of B and C is 5, and the average of C and D is 10. What's the first thing you do to translate the average of B and C is 5 into an equation?
I would do B plus C divided by 2 equals 5, and then the same thing for the other. C plus D divided by 2 is 10.
Perfect. That's exactly right. Now what should we do to get rid of those fractions and make these equations easier to work with?
Well, we can multiply both sides by 2, and we'll get B plus C equals 10 and C plus D equals 20.
Exactly. Now we have these two clean equations. The question asks us to find B minus D. Looking at these equations, we have B and C in one and C and D in the other. How do you think we should approach finding B minus D?
Oh, you know what? This came up yesterday too. I was trying to find numbers for everything, but you don't need to do that. You just need to have b minus d. So what we do in both is solve for b and d. We would get b equals 10 minus c and d equals 20 minus c, and we would subtract them from each other, right?
Perfect! You've totally got the strategy. That's exactly what happened yesterday, and you remembered. So now let's calculate b minus d. Walk me through it. What do we get when we substitute these expressions?
We'll get 10 minus c minus 20 plus c.
Perfect. You distributed that negative sign correctly. That's the tricky part. Now when you combine the terms, what do you get?
You get 30. No, wait. Oh my god. No. You get negative 10, negative 10.
Haha, yes. Negative 10. The c's cancel out perfectly, and you're left with 10 minus 20 equals negative 10. You caught yourself so fast. See how the c variable completely disappeared? That's the beauty of this approach. You never needed to find the actual values. Does this all make sense?
Yes, it does. Thank you. We can move on. I can't believe I got these wrong. These seem so easy. Am I a bad math teacher? I feel like I'm a bad math teacher.
No way! You're absolutely not a bad math teacher. These are classic test tricks designed to catch people under time pressure. The GRE wants you to overthink or rush. You taught math for 8 years and you caught your mistakes immediately once you slowed down. That's what good teachers do. They recognize patterns and self-correct. Ready for the next problem?
Okay, I feel like gassed me up a little bit there. I should have caught those mistakes. I should have caught them. Okay. So this one is a problem that doesn't have a diagram, but can be turned into a diagram. So I wonder how Lumi is going to tackle a problem like this. We can see that I am terrible at ratios and geometry because I didn't even know this rule, right? So yeah. Okay.
Hey Jin, I see you've uploaded another GRE problem. This one's about triangle angle measures. Triangle PQR, where angle P is between 20 degrees and 40 degrees. Angle Q equals angle P, and we need to find which measures could work for angle R. Classic select all that apply with inequalities. What's your initial thinking on this one? How do you want to approach finding the possible range for angle R?
Yeah, so on the GRE, I was like, should I just make the angles the same and count? But that would be insane, right? Because there'd be so many angles that it can be. Can you walk me through what's a good way to do this one? A good way to tackle this?
Yeah, testing every possible angle would be a nightmare on the GRE. The smart move is to find the range of possible values for R using inequalities way faster. Let me show you the strategy. Okay, so we know P is between 20 degrees and 40 degrees, and Q equals P. Now, what fundamental property of triangles can we use to relate P, Q, and R?
Oh, I just got it. Okay, hold on, I just figured it out. It would be 180 minus 40 and 180 minus 80, and R can be anywhere in between that range.
You're so close. I love that you jumped straight to it. Let me just trace through your logic to make sure we nail this. So you're saying 180 minus 40 and 180 minus 80. Walk me through where you got 40 and 80 from.
Why are you saying 4080? It's 40 and 80, right? But it's because if P and Q are the same, and the smallest they can be is 20, and the largest they can be is 80, sorry, and the largest they can be is 40, that means that 40 degrees would be taken up if they're both 20, and 80 degrees would be taken up if they're both 40. And since there's only 180 degrees in the triangle, we subtract 180 minus 40, and we get 120, and 180 minus 80 and we get 100. So R has to be between 100 and 120. Wait, you like wrote over some things and now everything's overlapping. Can you start over?
Okay, fresh start. So your logic is perfect. When P and Q are both at their smallest, that's 40 degrees total. And when they're both at their largest, that's 80 degrees total. Now here's the key question. When P and Q together equal 40 degrees, what's left for R? And when they equal 80 degrees, what's left for R?
Oh yeah, wait, no, sorry. It'd be 140 and 100. So R is between 100 and 140, not 120. I said 120 before. Did you get stuck? It seems like you got stuck.
Haha, no. Not stuck. Just wanted to show the calculations. Yes, you got it exactly right. R is between 100 degrees and 140 degrees. So on your GRE, you'd select all answer choices in that range. One important thing though, can R actually equal exactly 100 degrees or exactly 140 degrees?
I want to say no because you asked that question. Uh, but the answer really is no because it's less than or greater than, not less than or equal to, greater than or equal to. So if it said 100 as an answer choice or 140, I wouldn't pick those. I would pick everything that's above 100, including 100.1, or below 140, including 139.9.
Perfect! You nailed the inequality logic. That's exactly right. Since P can't actually equal 20 degrees or 40 degrees, R can't equal 140 degrees or 100 degrees either. So you'd pick everything strictly between those values. 101 degrees, 110 degrees, 125 degrees, 139 degrees, etc. But not the endpoints. You totally figured this one out. Does this all make sense?
Yeah, it does. We can close the whiteboard and I'll upload the next one. We have a few more to get through.
All set. Ready to tackle the next GRE problem whenever you upload it. Let's power through these.
Okay, that made sense. Okay, next one. I think that was this one. Yep. And so we got two more. We got this one and this one. Ah, both function problems. Good. I'm getting kind of bored of the ratio. I understand why I was bad at ratios. I get it now. I feel like I can do any ratio problem. Don't quote me on that though. Uh, and now I want to do I want to do something else. I get ratios. I think I kind of get geometry now. Uh, yeah, we'll see. Some algebra would be nice.
F. I notice you've already marked f equals 3 divided by x squared as correct and crossed out f equals 3 plus 1 divided by x. Do you want me to verify your answer is right? Or would you like to walk through your reasoning for why you picked 3 over x squared and eliminated the others? What would be most helpful?
Actually, this was graded, and so the one with the green marking is correct, and the one with the red is what I picked. So I just got this one wrong. I just want to understand why I got it wrong and how to solve it correctly.
Oh, got it. So you picked f equals 3 plus 1x, but the correct answer was f equals 3x squared. Let's figure out where the thinking went wrong. Can you walk me through why you chose 3 plus 1 divided by x? What was your reasoning when you evaluated f and f for that function?
Uh, I actually genuinely don't remember. The test was like, I think I took it like a week ago.
Ha! Totally fair. A week ago is ancient history. No worries. Let's just work through both functions fresh and see what happens. Let me show you the comparison. Let's evaluate this together. What's 1 divided by negative 1 half?
uh, 1 divided by negative 1 half would be 1 over 1 times negative 2 over 1, so negative 2.
Perfect. So negative 2. Now what's 3 plus negative 2?
3 plus negative 2 is 1.
Exactly. Now let's check f of 2. Is 1 greater than 3.5?
Yo, are you condescending? That sounds sarcastic, but no, I get it. I get it. You're asking me because you really want to know if that's the misconception. That's not the misconception. I must have made a calculation error.
Haha, no. Not condescending at all. You're totally right. 1 is not greater than 3.5, so this function doesn't work. Now let's look at the correct answer and see why it does work. What's negative 1 half squared?
Negative 1 half squared would be. Oh my god, it would be positive 1/4. It's positive. I think I left it as a negative.
There it is! Yes, that's the sneaky part. Squaring a negative gives you a positive. So, boo! 12 is definitely greater than 0.75. So the key difference was that the x squared in the denominator turned that negative into a positive, which made the whole thing way bigger. Does that click now?
Yes, and I think I know. Okay, so I think what I did here was that I knew the reciprocal would be like not the reciprocal. Fraction division would be the answer because that's the only way to get a fraction to be greater than a whole number in a function, at least that I can think of. So I think I just kind of guessed when, because I left a negative and it would have been 3 divided by neg times negative 4, which is negative 12. Uh, And so I just was like, ah, I don't know this one. But man, I can't believe I didn't catch that. I can't believe I guessed. I tell my students don't guess all the time. Only if you're running out of time. But yeah, this makes sense now. We can clear it. We'll do the. I have one more problem to do and then we're done.
Haha. Hey, don't beat yourself up. You had the right intuition about needing division fractions to flip the magnitude, and that negative squared mistake is so common under test pressure. The good news is you'll never miss that again. Alright, let's knock out this last problem. Upload it when you're ready.
So like, am I just bad at? Is it that it's a test? Is that what it was? Okay, so this one you can see I picked 13 and it wasn't even close. So let's see if Lumi can salvage this one for me. I don't know if you guys can hear the dog sleeping. He's sleeping. I hope it's not too loud. Also, does it say how long I've been streaming for? I guess OBS would say that. What does it say? It's been oh, about 41 minutes. That's like length of my like average stream, which is good. It'll be makeup for last night, and then I'll stream later today. Although I like keep looking down to see my viewers, and I have one, and I think that one is me. So yeah. Okay, let's see.
Hey Jin, welcome back. Alright, last problem. Let's finish strong. I can see you've got a rational inequality here with some answer choices marked. I notice you have 14, 15, and 16 checked. And there's something interesting going on with 13. Looks like you marked both an X and a check mark on that one. Tell me, what's making you uncertain about whether 13 should be included or not? What was your thought process there?
So yeah, I actually didn't even know how to solve this one, so I kind of just guessed 13, and the answer was not 13, the answer was 14, 15, 16. So can we just go through how to solve problems like this, and then, yeah, from the top, please.
Absolutely. Rational inequalities can feel tricky, but there's a systematic approach. Let me walk you through this one from the top.
I just need to- Uh, hello?
First key step is to factor that denominator. What can we pull out of x squared plus 2x?
Well, we can plot an x, and it would become x times x plus 2. Oh, is it? I'm writing. That's what keeps cutting you off. Sorry, I don't mean to keep cutting you off with my loud writing.
Haha, no worries at all. Yeah, the voice activity detection is probably picking up your writing sounds. Totally fine. I'll just keep going. So, perfect, you factored it to x. Now here's an important question before we continue. What values of x would make that denominator equal 0?
Wait, but the denominator can't be equal to 0. That would be bad, right?
Exactly right. The denominator can't be 0. That would be undefined. So which specific x values would make x equal 0? These are values we need to remember to exclude from our final answer.
Oh, these. Okay, okay. So, 0, obviously, and then -2 would be the two answers we can't use.
Perfect! X equals 0 and x equal 2. Now, the key strategy for rational inequalities is to combine everything into one fraction. So we need to get a common denominator between these two fractions. What would that common denominator be?
Bro, what? Common denominator? I guess 5x times x plus 2 would be the common denominator.
Yes! Exactly right. The common denominator is 5x. So let me show you how we rewrite both fractions with that denominator. Now we need to simplify that numerator. Can you distribute the x and combine like terms in 15x minus x?
Oh, wait, one sec. Let me just write this down because actually, I'm that makes sense. One sec, one sec.
Take your time. No rush. Writing it down helps solidify it. Let me know when you're ready to continue.
Okay, I'm ready. What do I do now?
Perfect. Now we need to simplify that numerator. 15x minus x. Can you distribute the x through that and then combine like terms? What do you get?
Oh yeah, we'll get negative x squared plus 13x.
Perfect. X squared plus 13x. Now we can factor that numerator. Can you factor out the common factor from both terms?
Wait, don't you mean negative x squared? Also, can you write that step out so I can see it?
Absolutely. There it is. Now, can you factor out an x from negative x squared plus 13x? What do you get when you factor that?
Yeah, we get x times negative x plus 13.
Almost. You factored out x, but you need to factor out negative x to keep the signs right. When you factor out negative x from negative x squared plus 13x, you get negative x. Let me show you.
But wait, why do we have to factor out negative x? I don't really understand that.
Great question. You don't have to. You could factor out regular x too. But here's why. X is cleaner. When you have negative squared plus 13x and factor out x, watch what happens. If you multiply negative x by, you get negative x squared, and negative x by negative 13 gives you plus 13x. That matches. If you factored out positive x, you'd get x, which also works but has a negative inside. Either way is correct, it's just cleaner to pull the negative out front. Make sense?
Oh, it just looks nicer? Okay, fine, fine. I do like things that look nice. So, okay. So after we factor out the negative x, what do we do now?
Haha, perfect. Now, here's the cool part. Notice we have x in both the numerator and denominator. We can cancel them out. But remember, we still have to keep x equals 0 as a restriction. Let me show you what we get. Now we need to find where this expression is negative. We do this by finding critical points. Where does the expression equal 0 or become undefined?
The expression equals 0 when x is 13.
Perfect. X equals 13 makes the numerator 0. And where does the expression become undefined?
It becomes undefined at x equals -2.
Exactly. And don't forget, we also have x not equal to 0 from our original restriction. So our critical points are x equals -2, x equals 0, and x equals 13. These points divide the number line into 4 intervals. Now here's the key strategy. We need to test a value from each interval to see if the expression is positive or negative in that region. Let me show you the intervals. Let's test x equals 14. Can you plug 14 into our expression and tell me if it's positive or negative?
Oh, I see, I see. Yeah, yeah. So it's every number over 13 because if you were to use a number under 13, it's positive. But if you use a negative number, it's also going to be positive. Uh, so you have to use all positive numbers greater than 13, which is why the answer is 14, 15, 6. Because 13 is 0, so that's not less than 0. So it's 14, 15, 16, and above. And all the other regions, they fail.
13 works, and you're right that 13 doesn't work because it equals 0. But here's the thing. You said all the other regions fail, but actually there's one more region that works. Remember, we have 4 intervals to check. What about the region where x...
Sorry, I cut you off. Sorry, sorry. I'm just moving around a lot. What the region where x what?
No worries. What about the region where x is less than -2? Like x equals -3 or -5? Try plugging in -3. Would that make the expression positive or negative?
It would make it positive because -3 minus 13 is -16, and then you do -16, which is positive 16.
Good thinking on the numerator. But don't forget the denominator. Let me show you the full calculation. The numerator is positive 16, but the denominator is -5. So the whole fraction is negative. That means x.
Oh, yeah, yeah. So I would have to pick all the answers less than -2 and greater than 13 because I forgot to calculate the stupid denominator because it can be negative because of the x plus 2. Duh, duh, that makes sense. That makes sense.
Exactly. You got it. The solution is x.
You keep stopping after you say x. Is everything okay?
Haha, sorry. Yeah, the voice detection is probably cutting me off when you're writing. Let me finish. The solution is x less than -2 or x greater than 13. So from the answer choices given, only 14, 15, and 16 work. The full solution set includes all those negative numbers less than -2, plus all numbers greater than 13. Does that all make sense now?
Yes, yes, it does. Okay, it does make a lot of sense, actually.
Perfect! So the key takeaway for rational inequalities: factor everything, find your critical points, then test intervals to see which regions work. The denominator signs can totally flip things, so you gotta check both parts of the fraction. Any questions before we close the whiteboard?
No, but this is making me realize that, man, I'm kind of rusty on my GRE math, and also I need to get better at working under pressure, but I thought I always did well under pressure. But you know, if these test results are anything, it's that I don't. So when I create the study plan later, I should probably keep that in mind.
That's actually a really insightful observation. The good news is, you know the math cold when you slow down. You caught every mistake immediately once you step back. So it's not a knowledge gap, it's about building those timed practice reflexes. When you work on your study plan, definitely include time drills where you practice these multi-step problems with a clock running. That'll train you to spot those denominator tricks faster under pressure. You've got this.
Okay, so I wonder how long that was. Did that go over an hour? We're at 55 minutes. We're almost over an hour. I'm gonna have a lot to edit this week for the video, the YouTube video. Okay, that's all of my GRE problems reviewed. If you missed the first set of GRE problems, they are in the streams before this one, obviously. Feel free to check them out. It really shows how Lumi can work through this math. I think later today what I'm going to do is create a video for the parent dashboard. I have a few streams under my belt at this point, and my parent dashboard for this account should be relatively filled with insights. We can even see here I have a parent assignment, but I'm talking too much. Thank you for anyone who stopped by. Although I think it was just me. I don't know. I think it was just me. Yeah, I'll stream again later. We're gonna do creating the study plan with Lumi, and hopefully we can start studying for this GRE. Every day I'm going to practice all the math that Lumi recommends, and going through all the lesson Lumi recommends, and just making sure I'm ready for the GRE when I take it in a month. I'm gonna try to take it before Christmas. It'll be a nice little Christmas present to myself. Like, hey, this is how you did. This is the percentile you're in. To show students that this is a good way to prep. Okay, thanks anyone for stopping by, and I'll see you guys later if you catch me later. Okay, bye-bye.